Hello and welcome back. We have been adding features to our basename utility, but the only way we have been making sure that it works correctly is by trying examples by hand. We have seen a few examples of that. We added an option A, then we made sure that our program behaved the way we wanted it to, which for even moderately sized programs is not a good idea. As programs become larger in complexity, you need different ways to test them and to make sure that your new changes do not break any previous code. If you rely on just manual testing, you'll run into a lot of issues. What if you forget to test with some inputs that you tested last time? What if your tests have become numerous? You don't want to be there typing these commands for like an hour to make sure that everything works as programmed. Let's first start with an introduction to the virtual environment in Python. As you've seen that up to this point, we have used Python, the interpreter from your distribution or your operating system. We used the sys module to find the arguments to the program. But there are other modules, for example, XML or testing or parsing. How Python does this is you could either install these programs using the pip command for your system, which will install that module globally so that anyone can use it. But the problem with that is that it actually bloats your entire installation. If you are using NumPy, SciPy, pandas, and like 5 different things, and someone else is also using them, you might think, oh, it's a good candidate to just install those modules in the original Python installation. But what if someone else is actually managing a different version of a program which requires a older or maybe a newer version of pandas than you do? It's much easier to basically have a place where your particular program modules are stored, and the virtual environment module basically allows you to do that. So venv creates a virtual installation folder for your Python directory. venv creates a virtual environment for your Python so that you can install different packages to this folder. What I did was I called Python3 and call the module m. So -m says find a file probably named env.py and give it the parameter env. And what that did was invoke this particular module from the command line to create a directory where I'll store my virtual environment or all the packages I need. And you might see that that's pretty neat, that Python allows you to invoke modules from the command line using the -m switch. So you could have said something like sys. Sys is actually, I think, a baked in Python module. So you can't really use it like that. So what I mean by baked in Python module is that it's written in C, and probably that's the reason why it doesn't really let you. But a lot of modules you can simply call using this, like for example our own module, because this is written in Python. I can also invoke it as Python3 -m basename, and the only difference is it'll get the whole name. So now that we have got a virtual environment, let's enable that virtual environment, because right now we're using the Python from our original installation. Source venv/bin/activate. Yours might differ. You may have to look up the documentation for venv for your particular distribution or Windows or whatever system you're working on, but it should be pretty similar. And now if you see this text that at least in my terminal shows me a venv, that means that I have a virtual environment enabled. So if you look back at one of the first invocation of Python that I did, where my shell was not able to find Python. Now it should be. And what the virtual environment does is sets the correct path to the Python, and also a few other environmental variables. Let's start by installing pytest. What pytest allows you to do is lets you create test cases. So let's start with a simple example, then basename. I'm gonna start with, say, test f underscore f.py, and here I'm just gonna declare a function f which returns x plus 2. I want to make sure that this indeed returns a value that's incremented by 2, just to make sure that we understand how to test this. So I'm gonna import pytest. Pytest basically requires that you write a file. So any file that starts with a test or ends with a test is a test file. So pytest will collect all these files and assume that they contain unit tests and find all the tests which have this test in their name and run those. There's a document which tells you what exactly the test naming convention or the test cases in a given module is, and I encourage you to look it up. If you go to pytest website, you'll find the link to that module. But for now, let's just say that any function that name starts with a test is a test. And right now it doesn't do anything. We'll just run pytest. So it gives you some information. It says whatever the platform you have, the directory, and then it says how many files it collected. That means how many test files it found. It only found one because we only have this test underscore f here, and it ran one test which passed. That's all good, but we don't really have any test inside this function. So let's write a test. So I'll say assert f of 2 equals 4. If I pass 2 to my function f, it should return me a value of 4. So equal equal is the equality comparison, and assert basically says, does this whole expression evaluates to true or false? If it evaluates to false, then it raises an exception or makes the test fail. So let's try that. It should pass for us, and indeed it does pass. Let's try changing it so that it doesn't pass, or we hope it should fail. We see that it says an F here in the front of the files, which tells you that something failed, and then it gives you the reason for this. So it basically writes the name of the function. It points to the particular line where the failure happened. At least here it points that this function call evaluated to 4, and we compared that to 1, where 4 is equals to f of 2, and that's why it ran into an error. So it raised an exception called assertion error, and that's why our test failed. And that's a very simple way to test your program. Now let's extend our base name so we add more tests to this program. I'll create a new file called test underscore basename.py, and then I'll import pytest. So how should we go about testing this? One of the function that's like used by every single option And the program is the get basename function. If this function is not working properly, we can guarantee that everything else will fail. So it's really important that at least this function should return the right values. Well, we could try a few different variations on what kind of input basename can get and what should the expected output be. Before we do that, we have to import this function to our script. And how do we do that? So we'll just say from basename import get basename. So this syntax is different from this syntax when you say from and then you say the module name and you say import an object or a function. It only imports that particular value or function, object, whatever you call it, from that module. It does not import anything else, and that's really useful when you have a very big module, let's say, and you only want a couple of things from that module. It's a better idea to simply import it like that. This, however, it does not mean that you're gonna import everything from pytest. You'll still have to qualify everything with pytest dot something. Like if you say import pytest like this, and there is a function, let's say test something, so you'll have to call it like pytest dot test something. In this case, we can simply call it get basename. Both these syntax have their pros and cons. With practice, you'll know what to use in which situation. So let's write a function to test our basename. So again, I'll start with a function name which starts with a test. This function really need not take anything. Let's go back to our basename function. What kind of inputs will be useful? How about if the name is an empty string? In that case, we know that the basename should be the empty string. What if basename only contains a slash? In that case, our basename should be an empty string. What if the basename is just a single file name? Let's say compare, or just a single component in that name, and that should be the base name for that. What if there are two different components to a name? Then the base name should be the last component of that name. So we kind of have a few things that we can test it for. Let's go ahead. So I'll say if I pass an empty string to the base name should be an empty string. And if I pass a slash, like a name that's just slash, then it should be an empty string again, because there's no name in that path. What if there's a slash and there's a name after that? Then it should be that particular name. What if there's nothing? Still, we get the same name. What if there are two different components to this? Then still get that. So let's try, and you can see that pytest found two different files in this folder. It found test basename.py because it starts with a test, and it also found our other test file, which was test_f.py. It ran tests in both the files, and none of the files had a failing test case. So now we can hope that our basename is working fine. As you can see, there may be some cases which we haven't really tested. I would encourage you to add more test cases. For now, we can assume that at least this function works. Now let's move on to some other functions. Now let's try testing option_a. Testing get underscore basename was a little easier than just because it returned a value. In did not simply just print that on the screen. With option underscore a, you provide a list of arguments and you get an output on the screen. So we can not really do an assert like this. Like we cannot say assert option underscore a and pass it a list of arguments and equate that to some string, because option A does not return anything. What we have to do at this time then, we have to capture the output of option underscore A and make sure that that output is correct. We'll say test underscore option A. Pytest provides a way to capture the output. So if you want to capture the system output, you can pass in a capsys argument to your function. This variable captures all the output produced from that particular function and allows you to test that. So let's see how that works. For now, let's just try printing something to the screen. Hello from test underscore option A. Capsys. So we just say captured equals to capsys dot read out error. That's the function, and then captured dot out equals to let's see if that works, and then I'll go into what this is doing. So what's happening here is when you're inside this pytest, any function that pytest is gathering as a unit test, for example this and this, it saves the output from any print statement called directly or indirectly from this function inside capsys. That's what we did. We simply printed this string, then we used this capsys argument. We said give us the output from the whatever pytest captured, and then we said is the standard output equal to this string. And you may notice that I added a /n. That means a new line. So print by default adds a new line to the end of the string. Remember that we have to make sure that the whole string matches the output. So we cannot simply just write this and test it against rcapture.out, because print also added a /n end of this output or the string. So that's why we compare that string against the captured output from pytest. And so this allows you an easy way to test our option underscore a function. Before we do that, let's import that here. So if you are importing more than one functions or other values from a module, you simply separate them by a comma and not write a comma after the last import. So let's do this. We'll say option underscore a. So let's start with just a hyphen a, like there's nothing there. So I'm going to say, and I'm going to rename this to GV1, just so that when we test more, we can simply name that ARGV2 or RV2 and so on. Once option A is past this set of parameters, we know that with no files, it does not print anything out to the screen. So the outputs for our option A, when there's no name, is an empty string. And that works. Let's add one more case for when there's a single argument. Compare, and because this is a single argument, we know that it should print the base name for this argument, which should be compare, but we also know that option _a uses print to print things, and which adds a /n or a new line character to the end of every base name. So we also have to write this /n in our comparison. Okay, so what happened there was I forgot to save the file. Now let's test it with just one more argument with only one component in the path. So it should simply find the base name for the first one argument, or the first name, the base name for the second name, add a /n or a new line character after each of the arguments. Now that we know that most likely our option A function works fine, let's write a couple of tests for option _s. We start by importing option _s, and we'll have to do the same thing. We'll have to capture the output like we did in test option _a, and this time we'll start with option s argv1. We assume that our list to option _s will always have the suffix. Even if it does not have any name, that's fine, but it should always have a suffix. Just to illustrate a point, I'll pass in a list with only the option or -s and not include either the suffix or any name. And let's see what happens. We got an index error exception, and you see that our code was looking for a suffix and it didn't find any suffix because argv, so this s index +1 was out of bounds for this list. So Python never lets you access anything outside the list, unlike C or C++, at least with raw arrays. But Python won't let you do that, and so it raises an index error, which is the right thing in this case. What we basically want to instruct pytest is that in this case there will be an exception. Pytest does allow you to say something like this. So we are instructing pytest that there will be an exception called index error raised when you execute this function. If it isn't, then the test doesn't pass, because we want to make sure that our option _s raises an error where there is no suffix provided. If we do that, the test does pass. And now you might be wondering what's this with statement is. So with allows you to create a context block of some sorts. It lets you do something and then clean up. We'll go into much more details as to how to write your own class or how to use with your own programs. But for now, just think of it as a way to do something and then clean up. This is how we instruct pytest to make sure that there was an exception. And let's go back. I'm just going to copy paste this portion. What we'll say is, how about just a single, and when it's a single argument, that's the suffix, and so we shouldn't get any output from. I forgot to change the name of that function there. And so when only a suffix provided and no names are provided, we get the right behavior as no output. And now let's add one more test, and I'm just going to say /user/sort and compare. So one with 2 components, one with 1 component, and one with, let's say, stdio.h, and it should do that. So I'm basically just writing all the variations I can think of. C/n. So okay, so we just went over a bunch of different cases: 2 components, 1 component, 1 component which matches the prefix or the suffix, 1 component where it does not match the suffix. This was basically a way to make sure that we don't really have to write manual test. So let's say someday you make a change to option underscore a, and then you accidentally make a change that was incorrect. You can simply go back and run the test to make sure that your changes did not break a functionality. And you see how powerful that is? You don't really have to go over and write those 5 different manual examples one by one and hope that you did test the program correctly. When this particular function failed or why this assertion was raised, it helps you. Um, so right now you might not be able to see why or how it was raised, but we may go into debugging later in one of the later videos, see how we can use some of the tools to debug your programs. For now, we know the fix. We'll fix our code in record time, and well, everything works. And so from now on, as we go and add more features to our base name, we'll keep on updating our test suite. We may change these functions, like how they behave. Maybe we may change the way they do their function. Maybe we might find that it's a better idea to return values from functions like these functions rather than simply printing them to the screen. We'll just go and keep on updating our test suite so that we know that our program is working. And by no means this test suite is exhaustive, at least correct for most of the time, and only fails some of the time, I guess. Next time we'll look at providing 2 different options to basename. Right now our basename utility only processes 1 option at a time, so you can provide it -a or with -s, but not both, and that's a limitation. The Unix basename allows you to combine different options, which makes basename more useful. And so next time we'll look at combining different options and updating our test cases to make sure that we didn't break anything. I'll see you next time then.